And minimum, come what may, I always want to keep 2 running. Whether somebody is using it or not doesn't matter, but I'd never want to go below 2. So that is minimum and maximum, right? Hopefully this is clear. So maximum is always required. You cannot create auto scaling group without minimum and maximum. Okay. Now next thing, do I always have to rely on metrics which is reported by CloudWatch? In a way, yes. In a way, no. What if, let me give you an example. Let's say I am running a Uber-like system, Uber taxis. I predict or I talk to a weather website. I means my system, and that weather website reports back to me what is the probability of rain. So if probability of rain is more than 80% that evening, I would prefer that because of this, more people would be interested to hire taxis because they don't want to get drenched into rain. So I could check a data from weather station, and if says probability of rain is 80%, I could use this as a trigger for my auto scaling. And when this probability is higher, probably I would need more instances at the back end to handle the load which will be increased. And when this weather station says, hey, probability of rain is 30% or less, I could say, okay, let me remove those instances. So you could use some third party factors also through CloudWatch to be a trigger point for you, should not be a problem at all. So that is completely possible, right? So pretty flexible service, and you can use very innovative use cases with it, should not be a problem. Hopefully everyone is clear. Now, this was target tracking. Another policy we support inside this is called dynamic scaling with step scaling. How we do step scaling, let me again explain you by an example. I lived in Dubai for a long time, and one night I reached home from somewhere and I found that a nearby building was having a fire. There was a fire going on, that was a restaurant, and there was a fire. I called the fire department and they asked me a weird question. They asked me a question. They asked me, say, hey, tell us how big is the fire? Now, I have no idea how to define a fire or how to monitor fire. It should be meter, centimeter, kilometer, how I should say what the size of the fire is. So that was a little weird question for me to answer because I didn't have an idea that how to monitor fire or how to say how big is the fire. So question they asked me is that how big is the fire? I didn't realize what they mean by that. Then they explained me, and I was making that call first time, but they get these call every day. So then they started telling me, hey, tell us whether it is a room on the fire, or tell us whether it is a whole apartment on fire. Yeah, give me a minute. Whole apartment is on fire, or is it the whole building on the fire? Then I realized that, hey, they are trying to understand how big the fire is so they would know how many resources they have to send. If I said a room is on fire, probably they will send one vehicle, two or 10 men, and they would take care of that fire. But if I said the whole building is on fire, and Dubai buildings are like 40-story, 30-story sometimes. So that would be like all hands on deck position. Everyone has to be sent to that fire because there is a huge manpower required for it. So bigger the breach, more resources is required. Smaller the breach, less resources is required. That is what we mean by step scaling. Let me explain this information here into this format. See this one. What I am seeing here, I am seeing here step scaling. So I say if my CPU utilization goes from 50 to 60, add 2 instances. If this goes from 60 to 70, add 4 instances. And if it goes beyond 70, means I have a bigger breach. I want more instances to be added in this particular case. So bigger the breach, more number of instances has to be added. And that is also be possible through step scaling. So it depends on what policy you prefer. And it's not like either or policy. I could always have manual scaling. I could put schedule also, and I could track through dynamic tracking also. So these all policy work well with each other. They are not competing with each other. So they would be taking care of the way I want to run my auto scaling group. So this is the third type of policy, which is called step scaling or desired scaling, right? What is the last one? Last one is predictive scaling. This is little more newer policy than what we have discussed so far. Let me quickly talk about what we have discussed so far, and I'll go back to that slide. So we discuss about these three policies. If you look at manual, scheduled, and dynamic, these three are reactive policies. If this happens, I'll do that. If that happens, I'll do this. So they are all reacting. Manual, scheduled, and scaling, they are reacting. What if I can become little smart and be proactive? So that proactive scaling is called my predictive scaling. Let me explain what is predictive scaling and how it works. What predictive scaling is doing, it is keeping track of your previous history. It tracks your last 14 days utilization and based on that predicts when you may need more capacity to handle the workload which is coming up. Let me explain this thing here. See this. Without predictive scaling, what happens? This white line is my CPU utilization. So CPU utilization goes up. Okay, I would handle it by adding more instances. CPU utilization goes up again, I would add more instances. So in this time when instances are getting ready, my customers are still facing bad performance because instances may take little time to get ready. What if I could make my system smart and it captures my 14 days of data and based on that says when I would be needing more capacity and be upfront ready for that particular workload. As you could see here, what is happening? I anticipate my CPU would go high. Before that we added capacity. Again we were anticipating, we added capacity again and again and again. So this is becoming a predictive scaling. It is machine learning based model which detects your behavior from past days and based on that it is able to predict what is going to happen. That's what we call a predictive scaling. So it's a good thing and you could leverage it to get better benefit for scaling policy. So it is your decision how you want to leverage these specific services. All right, so that's how you would be able to utilize it. Can this 14 be configurable? I don't know what we mean by 14. No, 14 is not configurable. The number of days, no. Right now, the model predicts based on 14 only, not beyond it. So it won't be capturing your monthly cycles. It may be for weekly. For monthly cycle, I would say use your scheduled scaling. Now, a quick use case about Netflix. Probably everyone knows about Netflix, right? So this data which I'm sharing is from 2018. So it was obviously would have changed by now, but just it is a good example to see. So Netflix that time had 137 million subscribers, 190 plus countries, and they are supporting their service on 1700 devices plus devices, Apple iPhone, mobile devices, then maybe laptop, desktop, kiosk, smart TV, all these places. And how they leverage AWS, they were leveraging 3 AWS regions and see the number. 250,000 reserved instances. These mini EC2 machines they were running, and they have put them together into 20,000 auto scaling group. What you see here at the bottom are two pictures, two videos. One on the left is little dark, one on the right is little much better picture. Why it happens? Netflix detects your network quality and based on that streams a lower value output or a high definition output to you. So it depends on how much network capacity you have, how your network is performing, it would be able to add capacity, add better video or remove some pixels and give you a less quality video because continuity is more important than quality in streaming. So that's how Netflix is using this mechanism of identifying bandwidth and then deliver that type of video to the customer. And for that, they need capacity. So how they use this 250,000 instances, this is their regular streaming traffic. This is mostly driven by US, I would say. If you see here, around 7 p.m. every day, this is data from 2018, people come home, they have dinner, and now they are watching something before going to bed. So around 7 p.m., they always had peak. See this. Every day, around 7 p.m., they get peak utilization of their services. So that is what is happening. And once people sleep around 3 a.m., what is happening, as you could see here, around 3 a.m., they have the least utilization. 7 p.m., they have highest utilization. So their capacity is like this, which means their capacity is maximum utilized on 7 p.m. and remaining capacity is free till 3 p.m. So what they do in that case, what they do smart mechanism here through auto scaling. They use this capacity which gets free to encoding job because they have to encode their video for different video format, different monitoring station. So this is how they are scaling their environment and adding capacity back to streaming. Once capacity becomes free, they add it to encoding and bring it back to their regular streaming job. So all automated using 20,000 auto scaling group and delivering the performance which customers are expecting from it. So this is just a use case. I'll send you a link in resource page today where you can get more detail on how they implemented, what metrics they are monitoring, and how they run that massive global scale infrastructure.